Hello, my name is Liz Fiacco. I'm going to talk about making machine learning algorithms super adorable. So I'm sure if you talk about AI, this is kind of the thing that comes to mind. They're kind of freaky, they're spooky, they're scary, they might be homicidal, they're omnipresent, and they're dangerous fear machines. And honestly, there's a couple entities out there that are really trying to make this our reality. Not naming names. But the reality is that machine learning is weird and bizarre and kind of adorable, as evidenced by these super weird knock-knock jokes that it kind of generates, because it's sort of just trying to emulate what a knock-knock joke should be. Well, okay, yeah. Half of them are machine learning, half of them are humans, human children. So what I'm saying is machine learning algorithms are babies. So what do? Do we just like put some googly eyes on some AI, put some glitter on it, call it a day? No, we kind of have to look about what is actually going on that enables this. Machine learning actually is kind of this box where it kind of looks around at its context, it understands some information that you give it, and then it's just a guess machine. It says like, all right, okay, it's probably something like this, but maybe it's something like this, and I don't really know, which is totally opposite of like what we expect computers to do, what we expect programming to do. We expect that to give us a solid answer, but machine learning's like, but they're actually really precise with how much no they do, because they're still mathematical. So here's kind of a visualization. This is out of Unity, where you can kind of see these green bars here represent how confident these tennis rackets are in how much they're going to like be able to hit the ball and potentially get a reward at the end of this. So you can kind of see the tragedy that happens over on the right over there when it drops the ball. But the trick is you never would have known that unless I like explained it, right? Because it's not something we understand. We don't understand green bars. Like, we don't have green bars over our heads. We have faces. And suddenly this is a drama that we can understand. And the information is the same, but now we get it. We get it on a human level. So really the idea here is you can take a bunch of the numbers out of AI, you can squeeze all of these like heuristics out of these programs, and you can actually learn to characterize these numbers emotionally. So instead of something we really don't understand, like 78.36 whatever, we understand, we have a bad feeling about it, we're not quite sure about it. And the way we do this is, instead of trying to make our AI come across as this all-powerful, omnipresent, super faceless, like scary thing, we can make AI that actually communicates with us, and we can kind of communicate back with it and actually learn to understand each other. And I think that'll make the world a better place, because like, stuff's more fun when it's adorable. And that means that people might actually pay attention to what it is, and people might actually understand what's going on with it. And it means that engineers might actually be more careful about what kind of information they put in it. Because like, we know not to swear in front of children because they'll pick it up. But like AI, they pick up the same biases and the same bad habits that we'll introduce them to. Plus, if we make something accessible like this that anyone can understand, anyone can become a participant in nurturing AI and improving it and making it work better for us. Because nobody wants to live in a world where we're afraid of our software. Cool, that's my talk. Thank you.